Hello from the campus of Carnegie Mellon University in Pittsburgh. I am Joseph Yankel. We have a podcast today, a webcast actually, Right-Sized DevSecOps, how tooling complexity breaks modern pipelines. I get the great job of leading a DevSecOps innovations team at the SEI, and I'd like to welcome you today to our podcast webcast again. We like to make this as interactive as possible, so please use the YouTube area to post questions in chat. We will try to get to them during the presentation. And I also took a number of questions prior to this that we're going to try to address throughout the 2-hour talk today. I'd like to introduce my guest speakers today. David Shepard. Thanks for joining, Dave. Dave's been at the SEI for over 15 years, and he's worn many hats in software engineering, right? From network administration to big data to being a forensic examiner. Again, loads of experience in this subject. He's now on the DevSecOps team where he continues to help our customers solve complex challenges. Thanks for attending, Dave.
Thanks.
All right, next we have Vaughn Coates. Vaughn Coates, it's been about 4.5 years at the SEI. And before that time as a software developer, the past few years, you've been really focusing on observability and the challenges there in DevSecOps of how to really get that data, how to gain insight into the things that we're seeing and the things we don't know. And so, Vaughn, thanks for joining us today.
Yeah, it's nice to be here.
So this talk, Right-Sized DevOps, I'm kind of excited about it. How did you come up with that term, and what's it mean?
Yeah, so there's a couple ideas sort of came together. One was a friend some time ago said to me, I can't imagine how I could even do a lot of this DevSecOps stuff. The projects I work on are 2 weeks long, from the time we start them to the time we end them. I don't have time to spin up all this machinery and configure all these things. It's just, it would just take too much time, too much effort. And I really thought about that, and it doesn't have to be that complex. The minimums that you need, which we'll get into, really aren't something that should be overbearing too much for people to deal with, to be able to get some benefit out of having a process. The other part was for our own projects, right? We have an open source projects that we work on. One of them being Polar, and in putting it out there and sharing it with people, we didn't just want to share some source code and some binaries. We wanted to, give people the tools that we use to build and work on this thing if they wanted to contribute to the project. So in thinking about that, what we came up with was a solution that allowed us to do basically the same development level of process that we would use to work on this project ourselves and to share that with others. We're a DevSecOps team, so
right.
So we want to make sure that the people are thinking DevSecOps when they're working on stuff for us. So
excellent.
Yeah, it was a really good time, honestly, because we really had, early on, there were people who really wanted to contribute, even like here internally, right? And we got to see, I think pretty quickly, like how fast we got feedback from that, right? There were at first, we had a lot of scripting, we had, a lot of, system dependencies we didn't do. Some people weren't using the same machine. So it was very quick for us to get that, hey, like this script isn't working here, or like, hey, I can't just install the source code on my machine right away, right? We had to really think about a lot of we had to really take the stack all the way down to think about that stuff.
Yeah, and you start to see benefits that you really hadn't even anticipated, right? When you are able to just immediately give someone a fully reproducible environment and just say, use this, right?
So folks are asking, what is a streamline? What does a minimal set of tools look like? I want to do CI/CD. Are we talking about those kinds of things?
Yeah. So I mean, the absolute minimum you need for any pipeline, right, is going to be a version control server, and a CI/CD server to do, build, test, whatever else you want to do. Maybe a registry, right?
Yeah, a place to put things, a place to like actually you store your code, right? Then you do your build and test, but that place to put things, I think, becomes really important once it's time to start thinking about compliance too, right?
Yeah.
Yeah.
If you're going to do DevSecOps style testing, you should choose at least one sort of testing tool as well to put in there. And that thing should probably be specific to your needs of your project.
Okay, so I'm hearing version control, some type of build automation, CI/CD, some type of testing framework, whether that's quality, security.
Yep. Could be both. But the other piece is, right, the piece that sort of ties all that together is the artifact that you use to run through that process, through that pipeline. In our case, a container, right?
Mhm.
We use a container as our currency for working on things, right? So whether we're doing things locally, doing development on a local system or in the cloud or something like that, or doing CI/CD, right? We can basically use the same container foundation for all of those purposes. Toss it in a runner, and you get the same sort of product that you would locally, which is ideal, right? Repeatable environments, both from a tooling perspective and from like the thing that you're producing.
Yeah. And that really changed the game. That changed the game working on the project, honestly, a lot because, at first, like I think I was slow to adopt it, wasn't I? At first I was really committed to doing development locally. Because, I'd already come so far, right? Like I've been working with the machine I've had for a few years, right? Like I already did the work of installing everything. But then I went home and I was on another machine and I realized I hadn't done all that work that I had did before. And, and when it came time to start doing that, I just eventually, I just cracked, right? And I said, okay, I really have to give this thing a shot. And when I did, I was almost blown away myself, given the amount of work that took to really do, because, as I started contributing to that, I realized we really had to understand a lot about our systems and our dependencies to get to that point. It wasn't just getting the source code to work, right? Getting the Rust toolchain that we were using to work, but making sure something like SSL, OpenSSL was configured, right?
Yeah.
Making sure that we had our compilers there, all that stuff.
I mean, so there was a time, right, before containers, if you want to go back in history here,
Yeah.
We didn't have the option of just giving someone an environment to, start, right? Unless somebody took the time ahead of time to build it out for them, right?
Oh, the golden image.
Mm-hmm. Oh, yeah.
The golden image, or the golden wiki, if you will,
Mm-hmm.
right? Here's a page of instructions. Let us know when your build environment, your development environment is working, right? And then you can start working on your project.
Yeah. And how long do you remember how long that would take to get through for you?
It was actually a wicket,
Yeah.
right? If like people couldn't do it, they maybe had to go do something else.
Yeah. Yeah.
It could, depending on the project, it can be a significant ramp, but you really don't want to spend that time, right? Not just to get someone started working on something. It's kind of a waste, right? I mean, it's not that you don't want people to understand how that stuff works eventually, but maybe not immediately, right? And so to be able to give someone an environment, just say, here you go, here's how you use it. It's good for everyone.
Okay, so you're saying a development container is one of your approaches to beginning this and reducing the complexity out there. Is that right? Because it sounds really easy. What's the complexity we're talking about here in DevSecOps?
Well, it definitely is. I mean, that is one approach, right? That's like a tooling side approach, right? To how you can begin to pare down some of your complexity. Maybe we should talk a little bit about the complexity, though.
Maybe we should, right?
Like what it looks like, why you would want to.
Yeah.
You want to pull that up?
Yeah, we can have.
So let's share with the audience. We do have an image of, what are we looking at here?
Yeah, you want to start?
Yeah, this is the Cloud Native Computing Foundation's CNCF landscape, Cloud Native landscape map. And what it does is it breaks down all of the different products and tools that make up their portfolio and organizes them in a way for, sort of by purpose, right? Whether you're doing application definition and image build, or you're doing scheduling and orchestration, you're doing CI/CD type stuff. These are in every category. There are just so many different tools and products. Some of them open source, some of them commercial products that are a possible solution to one piece of this puzzle of putting all this stuff together. Some of them are probably more familiar than others to people. But really, you could walk into any given environment and find not just a different path that gets people through to the resultant pipeline or whatever their build environment looks like, but you can also find that they're using multiples of these things, right? Have multiples of them deployed. It happens, right? So like you get, you have someone who knew how to use Argo and they're no longer with you, right? So now the person who's doing that job now, they're more comfortable with Flux. So now you have Flux in your environment, right? And this happens, right?
Mhm.
People, it's not a just pick one and go with it, right? A lot of cases you have multiples of these things at play.
Yeah, and there are a few of these we've used and use ourselves, right? Working on Polar particularly, trying to deploy all of its services in our cluster, we ended up realizing, okay, we're already inheriting Kubernetes and our cloud environment. So there came a whole set of problems with that. It wasn't just a matter of figuring out how we do development. Then there was like, okay, well, how do we actually get it there? And there was a lot, I think, that happened there, right? Like we had to decide, first of all, we have this dev container, that's great. So we were able to use that in CI, but then there came the time of thinking about, okay, how do we're going to create these Kubernetes manifests. We knew that, but how do we actually make sure that we can make it so other people can use them, And that's when we started thinking about some of these tools and we looked at them, and for a while it was Helm for a good bit, wasn't it?
Yes.
Yeah.
Well, so maybe I can take a
Yeah.
step back. So
Yeah.
these tools exist for a reason, right?
Yeah.
People have challenges and things that they would like to address and make easier for the people that are working on their systems. And in some cases, these tools are really successful at that, but they also bring with them, each tool, its own complexity, right? Its own way of doing things, thinking about the way things should work together, right? If you choose the wrong sets of pairings here, you can end up with a system that's very difficult to actually work with, right? And just to illustrate the point, like take Dapper, for instance, right? So Dapper is a really interesting tool. It creates an abstraction around like all of your deployed components of your application. It can deploy itself as sidecar proxies, right, to all of your containers, and be used as a service mesh. But you can also use it as with like a pub sub architecture, which those architectures are vastly different if you're building systems, right? And they have different needs and different concerns, and the way that you secure them and those sorts of things. So like, every one of these things has implications, right? On both what it's going to take to work with it, what that's going to look like in production, and whether or not it makes sense for the architecture of the thing that you are building.
Oh man.
So this is your complexity, right? I look at this and it's a little overwhelming.
I mean, all these are as icons.
Yeah.
I mean, you dig into the documentation. Some of these things are thousands of pages of documentation, each one of them, right?
Yeah. And
All right. And I've worked with a lot of customers rolling out Kubernetes, and there are some, I guess you were going to speak on that. There are some projects out there that have made some of this easier, but some of those projects also they're paving a road into a certain way of doing DevSecOps. And that's part of the challenge here, right? Saying generically, this is what this looks like, use what I've built.
Which mostly can work as long as everybody understands what type of applications you are planning to build with that solution, right? The form, the shape of the applications that you're building should resemble the form that architecture is designed for. So, and if it's not, that's something you need to think about, which is actually one of the things we ran into with our efforts with Polar, right? Polar is a pub sub architecture, and we wanted to do a zero trust boundary around things. And the deployment model, that thing looks very different than a service mesh, right? So if a service mesh is how you would think, well, this is how I'm going to implement zero trust, it has a lot of redundancy that's just completely, and complexity that's completely unnecessary to a pub sub architecture, right? And we could talk about that, but that's probably not the direction we want to go.
A lot of people do, right? They think service mesh, this is our solution. We're going to do everything here.
Well, unless you really understand what each one of these things are and what assumptions they've made and what, how the thing that you're building is supposed to work along with it, you really don't know, right? If these are going to help you or not. But also the fact that they come with a plan for you, maybe even leads you to build something that you didn't want to build, right?
I think that is a very good point, that because we ran into that exactly deploying the database for Polar, right? Part of its architecture is the knowledge graph database, and in trying to deploy all of our services into the cluster where a service mesh was present, it sort of got to the point where it almost kind of ate the database to a point, right? Like Istio, for example, is another service mesh that we've been using, and one thing it did was, well, it kind of manipulated our trust boundary in a point, because we wanted to have mutual TLS everywhere, but we couldn't get that because at the time, the service mesh wanted to inject itself in between that and wanted to terminate that TLS and actually make Neo4j speak basically plain text, right, to its own sidecar, so that it could then begin to talk MTLS to the rest of the cluster.
Yeah, no, it wanted control over that trust boundary.
Yeah.
Some here in custom solutions really have a hard time with generic architectures and solutions that are out there available for people. Your application and your infrastructure and your deployment model all have to kind of grow together.
I mean, unless you're building the same thing over and over, just stamping them out, most things end up looking custom, right? Or having special requirements or constraints, things that don't necessarily fit a cookie cutter mold, right?
Yes.
And when you start dealing with that reality, you end up fighting a lot of these tools, right? Make the thing work inside them.
I'm getting some questions around that. Hey, I'm trying to build multiple projects on multiple frameworks and technologies. How do I get some of the benefits out of here? I have to make a different pipeline, a different template for CI/CD as I go.
So so our concept with right sizing things leads you to a path where your infrastructure stack should be developed specifically to support the systems and the system or systems that you're building, and be developed alongside of it, right? So so that you don't end up with a situation where the infrastructure stack you have is far excessive for what you actually needed to deploy, or the reverse, right? It's not capable enough for what you wanted to deploy, and just bringing its own complexity to your environment. We see that fairly often, right? Where the infrastructure stack is actually considered and managed and built separately than the solutions that are being supported by it, right? And that causes this sort of thing, right? Where you have all these different tools and products, an opinionated way of how things are supposed to be done that may or may not make sense for what you're actually doing.
Okay. But some opinionated approaches do work. When do they work?
When you fit the cookie cutter mold.
Okay.
Right.
You got an example of that?
Web apps, right?
Yeah.
Like if your mission is to build and deploy web applications, absolutely, this is what this world was built for, right? If you find yourself needing to use custom hardware or custom operating systems or something like that, or maybe just you need control over specific aspects of the deployment scenario, like trust boundaries, you start getting outside of their mold, right? That a lot of these tools were built to help with.
Oh, that makes some sense. So the cyber physical world.
Absolutely, yeah. So cyber physical, they struggle a lot with being handed a solution for an infrastructure that presupposes how systems are supposed to be built that weren't at all considering the needs of working with sometimes prototype hardware, right? Not just different than the typical business application support type stuff, but just wildly unique, right? I mean, you can end up with all kinds of different stuff once you start getting away from, the typical business application.
Do you have an idea in mind? What's a right size approach for something like a cyber physical system? What might it look like? What's the most important aspect that you would say you should care about to begin? As far as a minimum set of tooling, right?
Oh, well, yeah, no, the minimum set is always kind of the same, right? For a pipeline, you need version control. You need some way of orchestrating a build, orchestrating a test, orchestrating a deployment, right? And the deployment testing, right? Some sort of analysis testing. When you speak of them more abstractly, right? It's all the same stuff. It's just instead of being able to use these tools, maybe it ends up being custom scripts, right? That you actually need to work with a specific operating system or to poke at a piece of hardware to get it into the right initialization state to work with it, right? Or to do a new deployment, or to write over some media at a hardware level to and then trigger a reset to actually run it, right? Like this is like the level that they're operating at. It's not all cloud native out there, right? It's not all just ask the cloud for a new virtual machine and you shall receive it.
Right. So I'm thinking, there's a minimum. We got to have version control. We got to have some type of quality security testing. But what do those things all really do? They just get all the stakeholders involved, right? This is really just core 101 DevSecOps, right? Engage that community, right? So we're not surprised. So early integration?
Early integration, not just of the pieces of your tool, but like actually bringing the people together with the right skills, regardless of what they do, whether they're infrastructure ops team or platform engineering or your developers, your testers, they all have a stake in this, right? And their input needs to be considered if you're going to put this together, right? The sooner you can bring those people together and actually give them all an opportunity to be heard and make them part of this process, the faster you're going to start deploying code. And that's really what we want. We want people building and deploying code.
Yeah, absolutely. Because I want to emphasize that point, right? Because I think a lot of the trouble people run into is something I think we said before in a previous talk, right? Is that integration is always, it's very slow and it's very expensive, and it happens too late. So when we say the word early, I want to qualify it and almost reframe to say that it should be more continuous rather than maybe only happen once per episode, right? Once per season, once per month or a quarter. Like once we get to a point of, everybody's in the same room kind of constantly, it's less kind of like episodic and it becomes more like, I want to use the word streamlined in that case, right? When everybody's consistently kind of able to say like, hey, maybe don't do that, right? If like security people are involved, we don't have to wait until it's finally handed over the fence to say, oh, maybe you got to take a step back, and go handle some of these vulnerabilities or some of these errors and things.
Well, something that I've seen is it actually forces some of these people to consider what their role is in their relationship to product development or software development. For instance, you mentioned security people, right? If you actually bring them into the conversation early, where they have an opportunity to see what you're building and to give you as a development team some thoughts on things they might want to think about if they're going to go this route. That type of feedback is invaluable early on to developers because they're not going to be surprised by it later on when they get handed an artifact and say this I can't put this into production, right? That's a bad feeling, right? So that's the whole point of doing integration early and often is to avoid that exact thing. But you can't just rely on software to do that for you, right? You have to actually bring the people together.
Right. And we're seeing some paralysis now, waiting on things to be perfect and ready to go before we even start building anything, right? Things never built so someone could maybe, if you are a cyber team and you're doing analysis later, you might just wait for things to be perfect. I've heard of problems just getting things on a network because we don't know what its vulnerability landscape is, right? We've heard of teams not being able to do their job because we're waiting on approvals to happen. But this is development, right? Should we not be constantly learning, constantly putting processes together that really make sure we're doing a good job here?
Yeah, and we absolutely should be. And I think a lot can, and that's why, like, if we still step back to the complexity problem, right, looking at the tool stack, so much can probably be eased by really just thinking about, again, like what it is you're actually trying to accomplish with that case. Because if you don't actually need to deploy yet, maybe you're, I guess, at getting to a point where you just want to share your code with some people, right, to start like working. I don't think that's not when you want to start. Maybe you don't need all that infrastructure at the time. You can just start thinking about, what's the fastest way for us to get to the point where we can get this in front of people and get that feedback. I think that's where you start really being able to actually just straight up disregard a lot of things at first and really just kind of focus on the problem you're trying to solve.
Yeah, I mean, you can't really deal with problems if you don't have something to put in front of people to consider, right?
So you're suggesting maybe an alternate approach to lengthy acquisition of compute, storage, memory, whether it's cloud native or local.
I mean, even the largest companies all start out small, right? Nobody starts out on day one with 10,000 developers, right? It almost always starts out with just small teams of people coming together around a very simple idea and building something, right? So having that huge machinery up front doesn't even make sense, right?
Yeah, at some point you have to say, create project. There's going to be that initial commit, and at that time, sometimes it's not even test ready. I think that's what we saw sometimes.
No, we see that we deal with this all the time, right? Especially with one-off open source projects, right? You're spinning something up for the first time. You always need the same basic things, but you're always starting from the same place, a folder, and it's empty. Right? You're going to start putting stuff in it, right? You've got your text editor. Maybe you've got your agent, your AI now helping you.
Oh, yeah.
Speaking of AI, is AI going to help here? Agentic AI, is it going to increase or decrease pipeline complexity?
I think there's real potential for it to decrease, personally, right? Insofar as if you brought in a specific tool that 90% of it you didn't need to solve some problem that maybe could have been solved with a simple bit of scripting, you can actually use the AI to help you write that.
I think that's that's definitely something I can speak to, because we got there, right? Thinking about deployment problems. That's when, when we got to the point of using type safe configuration, we're thinking about how to actually, take our deployment manifests for our services and actually get them onto our cluster. We used Helm for a long time, right? And at least I tried to. But there came to a point where I thought to myself, well, I just need Kubernetes manifests. So, I went looking, I went searching, despite you saying some time ago, hey, there's this cool language called DAL, why don't you check it out? And, that's when I finally made the switch. I said, well, this thing's going to do all my validation for me. This thing's going to, make sure that, all my manifests are great up front. So why don't I just do that? The only problem I had was, sometimes the manifests are one-to-one, right? I'm taking, this language, converting it into YAML and feeding it to my Kubernetes cluster. So, I sat with myself for a minute and I thought I can just write a bash script for that. And then I just was able to happily, and any LLM will churn that out for you, right? And that's what I ended up using. So once I had that piece, bye-bye Helm, just like that.
Right. It just isn't even getting in your way anymore.
Yeah.
Right?
Is AI replacing the user here? What are we talking about?
Absolutely not. I think there's a very important qualifier to that, right? Is that, I think LLMs are really only as good as the people using them. So you have to really come to a point as to understand like your environment, understand like what you want to accomplish there still. And then, I don't know, maybe just use it with a bit more
and just specifically the thing you were talking about with getting the manifests, there's a pattern we call the rendered manifest pattern, right? So, and it's designed to provide you better visibility, better observability into your deployed environment, right? There's no trying to read through the tea leaves on what the Helm chart actually did. Mm-hmm. You know what it did to your infrastructure because you have the fully rendered manifest before you applied them, right? And then you keep those things either in version control or in your registry or something like that. And then
because that's what they became, right?
Yeah.
Like the manifests themselves ended up becoming just these other static artifacts that we can just keep. And there were a number of tools at that point that weren't Helm that'll let you just kind of take that entire directory, those entire bundle of folders, and just kind of zip them up into another OCI artifact like Helm used to. And if you're using something like Flux, you can just feed that. And that's what happened.
Because ultimately that's what Flux wants anyway, right?
Yeah, that's all.
It just wants to manifest.
Yeah, right. So like we didn't need this anymore, and it was at that point what we got out of it was insane, right? We got all the validation we wanted, and we got to actually start thinking about our configuration like developers. We got to use a whole programming language to define like all of our constants, the different values we wanted, similar to how Helm wanted. But now, we got validation as well. We didn't just get more YAML, which can still.
Let me tease on that one point. You're saying the state of the art today is we have Helm charts and we have to customize these, right? Customize to have individual dynamic kind of environments, right? For different people.
Yes.
Right. We deliver Helm. Everyone edits Helm via customize.
That's right.
Now you're speaking of a configuration language that's creating these charts from the get-go and validating them, right?
Yeah.
What's that tool's name again?
It's a programming language called DAL.
DAHL?
DHALL, yes.
Oh.
So,
it's designed specifically for writing configuration in a type-safe manner. And what somebody has done out there is an open source project out there that does this, is they track schema versions for different versions of Kubernetes. So as long as you grab their schema and the specific version that you need for your infrastructure, you can just use their schema definitions directly into your configuration and render your YAML, render your JSON in exactly the way that it was meant to be written, right? No errors, no guesses, first time.
And there was an amazing shift of thinking here because I remember back when we were first asked about like getting Polar onto somebody else's system, and the first thing they asked for were Helm charts, right? And I think that's what kind of started this line. But I think that's a very common approach, right? It's like, do you have a Helm chart? Not just because it's popular, but because I think it's the
base currency.
Yeah, there's the idea that we can that we as the developers of an application can somehow know enough or reason enough about, in a general sense, someone else's environment, which we have no idea what it looks like, right? To be able to, create some sort of baseline configuration that we can just hand to somebody with no problems. But like you mentioned earlier, Joe, people at the time, like if that environment is somehow different from our expectations, you can always reach for another tool, customize, and then you can go and use that. And, ideally kind of start layering things and patching things and so on and so forth. But we didn't need to do that with Dull.
No, not at all.
Right? Like we took the environment that we knew, using like our own primitives, our containers, and we were able to kind of construct that configuration from the ground up.
That's right.
Yeah.
And also I don't want to beat on Helm and customize too much, but customize is designed in a way to lead you to, these are the things that you can edit, right? If the thing you need to change is outside of this boundary, customize doesn't provide it for you, right? In fact, their trapdoor, their escape hatch, if you will, if you can't do something using that, is to accept JSON diff and JSON patch, right? Which you can use JSON patch specification without these tools anyway, right? as another approach, right?
It's just one of those things, I think. But that was actually eye-opening for me personally, because we eliminated that, and suddenly, our entire repo just kind of ended up looking like a handful of different tools at that point that we could count on one hand.
That's right.
Yeah.
Yeah. So that's kind of the win, right? Is what you end up with is a handful of technologies that are chosen by your team, that if they understand them, everybody understands everything, right?
Mm-hmm.
And everybody can work on everything. There's no special knowledge required for some specific set of tools that you may or may not have people on the team who know them, right? They become more generalizable skills then.
Gotcha. Hey, I got some good questions from the audience. I think it's relevant to this discussion on configuration language, and maybe, are you using these in Polar? But one was, with all these tools, like we're looking at CNCF, the landscape, what's the attack surface look like with this, and how do we deal with it? And how are you addressing some of this?
That's a huge part of the problem. Is it's kind of unknown, right? Once you've chosen your stack, that you actually have to do that, right? That threat analysis, right? To figure out what your vulnerability surface is to attack.
Every time you add one, it expands.
Yes.
Yeah.
Right. The SAST and DAST don't necessarily deal with source code mostly, right? We got to do other static analysis, security, AST testing, just to analyze the vulnerabilities and what they list as libraries in their open source, right? Yeah. So it does just grow this, right? And we kind of know that static analysis is it an endless loop? It really feels like one. I'm going to constantly evaluate and then monitor, right? I'm going to monitor databases for what are my latest vulnerabilities. Yeah. I have to continue this pattern. It never stops. We don't talk about it a lot. The static analysis infinity loop within the infinity loop.
Oh yeah, you're really playing an infinite game in software development, at least up until the point where the game stops and you're no longer using that software anymore. Every time you add something to your environment, you don't just take on the cognitive load necessarily.
What does Polar do? What have you done to right size or approach this via some of your techniques?
So a lot of what we try to do is bring what we understand to be interesting and or best of breed ideas for how to do things today, right? Regardless of if they're things that other people are using widely or whether they're just the right solution for what we're doing, right? We don't just grab a tool and toss it into the stack because it's what was available. We actually use the Nix package manager to do a lot of our build and deployment work, and it actually provides us some incredible benefits in doing so. Right?
Okay.
People will definitely get upset about the ramp up on learning this stack, but the benefits of it are actually really hard to get using other stacks. Right, for this sort of purpose, I get a fully vendored, version controlled, immutable baseline that's completely reproducible at any time, right, by using this type of tooling.
That's a powerful statement. That's
It is.
an ideal scenario, right? We want reproducibility, idempotency,
That's right.
and that's tough with a Docker file.
It's tough. It's tough anywhere, right?
Yeah,
right.
If that's the goal, though, you actually have to start with tools that can get you to that goal, right? In a reasonable manner, right? Like, I have this conversation with people, right? It's not that you can't use a Docker file to do some of what we do with Nix and a Flake, right? But actually getting the exact properties that we are able to get almost for free just by using this particular stack, achieving that with something like a Docker file is expert mode, right? Like you absolutely have to know everything that you are using and what you are doing along the way.
So this isn't new, right? There's concepts of lock files, right? We're talking versioning everything, understanding where it's coming from. So we're dealing with supply chain here, right?
Yeah.
Really. And observability, reproducibility. That's what you're really going with Nix, right? I can reproduce.
Yeah, I mean, if somebody says to you, solving the supply chain problem is really hard, that's an understatement, right?
Yeah.
It's just grueling, right? But if you don't start with a baseline of tools and technologies that can actually give you a shot at it, you're just never going to get there.
Yeah, that's heavy. It's also, I think, worth noting that that what we get, that when we say for free, it's almost literal, right? Because all of the stack is pretty much open source entirely.
Yeah, it's a confluence of ideas, right? Everything gets hashed. Everything has a configuration as code, build as code sort of definition, and everything ends up in content addressable storage, right? So everything that's built is cached, and everything that uses those sorts of dependencies can have their own set of dependencies that are specific to what that thing needed at that time it was built.
Yeah, so the visibility is off the charts there, right? So
yes,
the problem of ownership becomes a lot more, what's the word, apparent, because now there's a lot more. It's very much easier to see like when something changed, and if it did change, it doesn't necessarily just kind of clobber your dependency graph. That stuff is actually versioned.
Yeah, you've got it in version control. You create a lock file, you can actually go back and look at what was in the tool or product at an exact moment in time, right? If something were to happen, for instance, right?
When something happened.
So it's not another question, maybe it's a comment a little bit, is it sounds like you're describing the dev environment to be possibly more complex than the product solution you're trying to build.
I see them kind of as one and the same.
Yeah, I don't
think they should be separated.
You shouldn't, right? DevSecOps. We are talking about the merging of development, security, and operations, right? So
as someone is fond of saying, if I put a Postgres database in my solution, Postgres is now part of my application, right?
Right.
So there's no escaping that, right?
Yeah.
If you built your application around a technology, you now own the maintenance and care of that product or tool, right? And anything that happens with it, it's part of your application now, right? So be sure that you want to use that technology, right?
Right. So absolutely is the answer, right? Everything's more complex. We want to scrutinize all aspects of development together. It is harder if we demand security and quality, which we do.
Yes.
Right. So if the user really demands it, it's now got to be part of the product, which we don't typically think of paying for this in our product, but we should demand it. Is that right? Should we not demand that it's built and it's secure?
I mean, we absolutely should. And I think I don't think it's unreasonable to say that you pay either way, right? Because, you're either paying with time or you're paying with money or, sweat, right?
Well, the promise of a lot of these tools is just use this thing and you won't have to deal with this, right? This will make this easy for you, right?
Yes.
And it usually tends to be a situation where that's either pay me now or pay me later, right? You're going to pay for the complexity and the cost of implementing these things, whether it's an upfront cost in setting things up, or whether it's on the back end of having to mitigate some problem or deficiency in the architecture because you chose a solution as opposed to developing one.
Question on auditability. How do you create an auditable DSO process?
So, I mean, that's a lot of
Huh?
what we
It's a lot
get.
of work, right? But
Right.
yeah, I think it really comes for free by doing what we did, right? Because when we version everything, you know, if you use Git, if you're a fan, right, all that entire commit chain becomes your audit trail for figuring out like who did what, when, why, and then being able to.
So getting to a reproducible build, your step one in towards proving, auditing things. What else? Attestations.
Yeah, attestations.
Another topic.
Is really deep.
But a good way of what?
It's a good way of making sure that if you wanted something to be done, it absolutely got done.
That's right. Good way of verifying that you had a process and it was actually followed. It doesn't actually guarantee you a process.
Mm-hmm.
It's just if you do have a process, you can validate that the process was followed. But attestations will get into that. And who did it? Who did what? Or what did what?
It's very much, I think it'll create an interesting baseline to start asking the questions around why, not just whether something was done and how it was done, but you can start really looking at your system once you have that level of observability to start thinking about, okay, well, what effect did this really kind of have on us, right? I think it's a big problem, like we were describing earlier, that sometimes static analysis can be that endless loop. But if you start looking at not just like the tools and what they're doing for you, you can maybe start asking yourself, was this kind of a necessary step? Not necessarily, the static analysis itself, but if your pipeline's more complicated than it needs to be, that's worth thinking about.
So pipeline complexity, if you're building the two together, your solution and your pipeline, pipeline complexity in that scenario is directly affected by how you built your solution to the application's needs, right? For instance, I'm going to bring up the service mesh again. Right? So a lot of what service meshes do is designed to fix the deficiencies that are present in a lot of applications as they're built today, right? They didn't design a zero trust architecture when they built their product, right? They didn't think about failure modes and circuit breakers and these sorts of things when they built the thing. The service mesh provides routing and all these different features because it's trying to handle at runtime decisions that could have been made as part of an architectural decision as to how the product was built in the first place.
Way back in the meeting room when we were thinking about it. Yeah.
You're paying for additional complexity on the deployment side because you didn't spend the time up front to think about a lot of these things.
And who's usually dealing with that though? Sometimes that's either like a DevOps team or an infrastructure team.
It's definitely infrastructure platform teams, right?
Yeah, the devs aren't really. Sometimes maybe the devs are get to know about it later on when they have problems. But it seems to me that sometimes that's just something that infrastructure and DevOps teams just sort of take on their own.
I mean, this is getting into the weeds a little bit, but really what the service mesh is doing is it's taking advantage of the container abstraction to inject itself into your application's architecture, right? And if your developers aren't doing their own build and test, in a similar way, you can see things crop up in production that maybe weren't seen and weren't visible at all in development and test, right? So, there are consequences sometimes to these decisions.
I think there always are. 100%.
What is one of the goals with the right size DevOps to kind of discover these things early?
Yeah. If you actually bring people together and all of these different aspects, put them on in the same room with each other, and let them voice their concerns and make sure that those things are thought about and addressed early, then the thing that you end up with can look very different than, just choosing a stack and running with it.
I like it. We've always talked about culture. I don't want to get into culture on this talk, but it is people, right? Getting together, deciding on what needs to be done, and potentially just starting small.
Starting as small as they have to.
As small as they have to, based on requirements. There's definitely things coming through, policies, rules. I think what you're saying is we're often seeing you're starting with the big.
Engineering is meant to be an iterative process.
Yes.
Right. Start simple, make it work, and then expand on that. Right.
Yeah.
Yeah, I mean,
it is.
If you're lucky enough to start with a lot of people, I know some aren't, but if you actually have a lot of hands, then it kind of behooves you to not necessarily just move as fast as you can, but like you can kind of almost take all the time you need at that point to really think about the skill set that's available to you and what everybody really wants to do.
That's really what it comes down to.
Yeah.
Making sure that you have the right set of skills in the makeup of your team, regardless of what their job role is, to really think through the different parts of what you're doing, right?
I mean, yeah,
Absolutely. And you want to right size your team. And one way you get to the right size is you build early and often, right? And you identify what you're missing.
Yeah.
Right. If you're trying to actually deliver or deploy a product, you will quickly get to the decision makers that should be involved there, right? And you want to do that in a safe, early fashion because it's less expensive.
Oh, yeah. The quicker you can get feedback, the less it's going to cost you later.
Right. So this is really kind of agile DevSecOps 101 concepts, but we continue to miss them.
Yeah, I don't think it's something. I almost don't think we're even saying anything new at this point, right? Like, it was. I was actually kind of like blown away to find out, just the sheer. Like, I'm glad to see the sheer amount of options that's out there for anybody using the cloud and using, these new tools. But like, I was almost kind of shocked to hear that reaching for something just kind of right off the shelf was kind of the go-to, as opposed to sort of, I don't want to say like that people don't do this, but back when there were no tools, back when there was no like automation.
That's the world we come from.
Yeah, exactly. That's what I'm saying, right? Like listening to you guys talk about this, like there didn't used to be Kubernetes, right? And people talk a lot about now. It's like, how did Zuckerberg build Facebook, without Kubernetes and without like all this auto scaling cloud? But they did it by, really making a lot of things bespoke, like making a lot of things custom for them. So I think like getting away from that was probably really like it was a good thing, right? But we lost.
We went too far.
Yeah, but maybe we like lost something there, right? When the pendulum swung from a scenario where you were forced to think about those things, we're not oftentimes incentivized to anymore. I think that's like really maybe like part of it.
For sure. Yeah. For sure, right? Cloud versus owning your own infrastructure, these sorts of things, right?
I mean, it costs.
There's a cost to everything.
Yeah, you're paying one way or the other. But like even that, right? Like managing your cloud, also a problem. A whole other range of issues there. But that's a different talk for sure.
Certainly.
Mm-hmm.
Yeah, it seems like, we've been doing the right things for a long time. Like I said, there was a time before a CI/CD, but back then we just called it something else.
Yeah.
Right. It was build automation, and automation was a thing. It just wasn't, maybe it wasn't as easy. Some of these tools have really helped us. Dedicated build servers that used to be me and you, right, in schedulers and cron jobs, right? But we always knew to get the quality and validation of that product, we would have to do these things often as possible. It's just some of these tools and scaling to the cloud allowed us to be quicker to test, right? I could do this at scale.
Mm-hmm.
But we've always wanted those things. That really hasn't changed. So I think this comes back to the core principles of engineering have to be followed. You need good requirements, right? We need people to say, here's the minimum set of things that your product needs to do.
Right.
And then we We may not be able to. If we can, absolutely go buy a solution.
Yeah.
You can't
Just don't
skip
get
that.
to skip it.
Agile and iteration doesn't allow you to skip that.
Yeah, despite
We do want you to discover early what you may not have thought of, but you can't skip the plan.
Yeah, I don't think, and even the requirements sometimes don't seem like the problem sometimes. You know, it is that planning phase, I think, that's easiest to miss. Because again, we have all the tools in the world at this point. There could be more, but there certainly could be more. But you know, it's but really sitting down and like really talking through the problem, right? It really just can't be overstated. I think the importance of that one, like not just having the good requirements, but actually maybe understanding those requirements and how they play into your system. Hopefully I get the chance to do that some more.
Yeah.
Excellent. Let me check. We have one more thing I think we had from a previous question. Is there a, did we talk about this? Is there a viable set of principles that are needed to resolve the complexity issues in today's DSO pipelines? You had mentioned things like collapse stack.
Yeah, that's a big one I think I can talk to, because it really, I think the principle of collapsing the stack until it can't be collapsed anymore, I think is really one of the most pivotal pieces of this, because again, it just goes back to the complexity issue. If you find you have a tool that isn't necessarily carrying its weight, maybe it adds more problems than it solves, or you can really just figure out a way to reason around it, it's reasonable to disregard it at that point, right? Until maybe you absolutely need it, right? When it does something that you just don't want to or can't do yourself.
Make the tool prove that it needs to be there.
Yes, absolutely. Make it prove itself. Absolutely, right? Because that's another piece of it. You know, it's fine to reach for something, play with it for a while, but once you maybe try to show it to someone else and maybe try to get somebody else on the team to use it, and maybe they're having too much trouble, or, you know, maybe it even costs too much, right? Sometimes it's worth working around that. I think that's like that's the biggest component of this whole thing is, you know, make your tools prove themselves to you 100%.
Okay. What about ownership boundaries?
Mm-hmm. Oh man, we could talk a lot about this one, but you know, I think actually defining those ownership boundaries is important. I think once you've established that, sorry, Dave, you can speak to a lot more to this one than I can, I think, right? You know,
just because you bought a product or paid for support for a thing, the moment it enters your production environment, you own that thing.
Oh yeah, 100%.
Right. If someone has to come in at 4 a.m. because something went down, you know, that's what ownership looks like, right? You know, it's the choice to put those things into your environment and make sure they're patched, you know, constantly updated. The cost of ownership is very real. And whether you buy a product or you build it yourself, you know, you're going to get to own it. Every dependency you use, every tool you use, you own it.
Yeah, I think that part is wildly understated. I think in our industry today. Yeah.
The last thing you had was a topic called build to suit.
Oh yeah, I think that's the takeaway, really. You know, overall, right? Like once you kind of combine all these things and all these ideas, you know, I think it's easy to say that we do that, but in practice, once you put under a microscope, you know, that's when it's time to interrogate that idea. So when things are built to suit, they should just work, right? You know, your deployment should be push button. Nobody should have to be coming in at 4 a.m., you know, unless, you know, it's absolutely something terrible. But I mean, that's the takeaway we want from this, I think.
And so one of the things that we've tried to do with Polar, like I said, is use technology stacks that allow us to remove entire classes of concerns from our need to worry about them, right? Like for instance, memory safety is a big issue with some of the technologies that we're using. But
guys, we're gonna have to wrap up. I just want to say thanks for sharing your experiences today. Really appreciate it. To our audience, thank you for attending today. Please like and subscribe. If you've liked this content, feel free to share the archive with others out there. Lastly, our next webcast will be next week, January 12th. The topic will be software acquisition pathway, ready, set, go. The registration information's in the chat. We'll send out emails. Thank you for attending, and have a great day.